Okay, so for higher order derivatives, let's say we know that d dx is our first derivative. Now our second derivative is just derivative with respect to x of the first derivative. And that's denoted by d squared dx squared, which is your second derivative. Okay. Now if you take the derivative of that, so d dx of your second derivative, that's going to give you your third derivative. And it keeps on going to as high as you want. So if you have the derivative, let's say this is your 49th derivative here, then you end up with your 50th derivative. And it keeps on going and going and going until you reach some place where you want to stop, where you have your nth derivative, where n could be anything, or any whole number rather. All right, so let's say if you didn't want to write it that way, you can also write your first derivative as, well, you know that's f prime. Then your second derivative, you know it's f double prime. Your third derivative, once it gets past 2, you actually just write a little number in parentheses for your derivative. So this would be a little 50 in parentheses. Okay, so your nth derivative, whatever that n could be, it's just a little n in parentheses. Okay, so it just keeps going and going and going. All right, so we'll move that up a little bit. We're going to look at the derivative of sine. Okay, so let's say if we let y equals, leave it at y. Y equals sine of x. Okay, so if we get our first derivative, derivative of y with respect to x, that's going to equal cosine. Now if we get our second derivative, that's the derivative of cosine, which is negative sine. We get our third derivative, that's the derivative of negative sine, which is negative 1 times the derivative of sine, which is negative cosine. And we go to our fourth derivative. Uh-oh, don't need that parentheses here. And that's going to be equal to negative 1 times the derivative of cosine, which is negative sine. Negative and negative is positive, so you end up right back at sine of x. And it repeats that pattern over and over. So first, second, third, fourth, we know the fifth derivative would be cosine. The sixth derivative would be negative sine. The seventh derivative would be negative cosine. And the eighth derivative would be sine. And it just goes that pattern over and over. So you know any derivative that's a multiple of 4 is automatically going to be sine of x. So we can actually use that to find like high-level derivatives. Oh, let me clean that up. That 8's a little bit messy in there. Oops, so is that 6. There we go. All right, so we're actually going to use that to our advantage. All right, leave that up for a few seconds. Anyone's still writing? All right. Okay, so our steps to finding our nth derivative. Okay, so your first step, you're going to divide whatever derivative that is by 4 and rewrite as n equals 4 times k plus r. And we'll do all that in the example. Okay, where r is your remainder. Okay. So you're going to your second step, rewrite, let's say, the nth derivative of sine of x as the 4 times k derivative of x, well, sine of x, plus the remaining derivatives.
Pretty much your remainder is pretty much what it's going to be.
Exactly, yep, that's it. Because this, no matter what, is just going to be sine of x. So whatever you get here, you say, okay, if we have a remainder of 1, we just need the first derivative of sine of x.
So like 12 would be 1.
Nope, 12 would just be, since that's a multiple of 4, it would just be sine of x. Yep, 13 would be 1, 14, 2, 15, 3, then 16 will go back to sine. So it kind of rotates there. Okay, so it's plus is probably not the right word. More like apply of sine of x. Okay. And here is where your r derivative with respect to x is going to equal your actual derivative of sine of x. Is your nth derivative. Okay. Now in this case, your r should be less than 4. So it should be 0, 1, 2, or 3. If it's 0, then your answer is just going to be sine of x, because any fourth multiple of sine is, fourth derivative multiple of sine is just going to end up right back at sine. So if r equals 0, your derivative, or your nth derivative, is sine of x. Okay. If r is equal to 1, 2, or 3, your nth derivative will be the derivative of that number.
with the prime and close rule as well?
Not for those, it wouldn't work, only because this only applies to sine. Because it's a different pattern for cosine, it would be a different pattern for everything else. This pattern only works for sine. But you can come up with kind of like the same
But like if
method.
So whatever the cosine is, it will be similar.
Actually, all of these are just sine. So you'll only see sine problems.
Okay.
So like, for example, if you were like cosine, it just started off as cosine, then the one would be negative sine.
Right.
And
Yeah.
it's like the next pattern over.
Yep, so now you just have to do that same pattern. All right.
Once you get down to like tangent and stuff, it's a lot harder.
All right, so let's say, for example, what is the 49th derivative of negative 4 sine of x at the point x equals pi? All right, so our first step is we want to divide 49 by 4. Yep, so we have 49 divided by 4. 4 goes into 4 once. 4 goes into 9 twice. 4 times 2 is 8. So you have a remainder of 1. Okay, so we know that 49 is going to equal 4 times 12 plus 1. Okay, all we want to do is separate our remainder. Okay, so your second step, so we know negative 4 and the 49th derivative of sine of x is going to equal negative 4 times the 12 and 4 is 48. So that's the 48th derivative of sine of x. And the r equals 1 derivative. Okay, so we have 48 derivatives and one more derivative after that. Okay, so we know since this is a multiple of 4, that's just going to be sine of x. So it's going to equal negative 4 sine of x, and you're just going to apply one more derivative. Okay, so the derivative of that sine of x will give you your answer. So whatever your remainder is, that's really just going to be the derivative you apply, because everything else before that just brings you right back to sine of x. Okay, so the derivative of negative 4 sine of x is equal to negative 4 cosine of x. Okay, so that's actually our 49th derivative. Negative 4 cosine of x. Okay. Now when x is equal to pi, since we can't forget about that x equals pi, when x equals pi, you get negative 4 cosine of pi. This is just negative 4 times negative 1, which is 4. Okay, so we know the 49th derivative of negative 4 sine of x at x equals pi is 4. All right, so now, no matter how big the derivative is, once you divide it by 4, whatever that remainder is, that's all you have to find the derivative of. All right. So any questions on that one? Yes.
So like, say we have -4 sine x and you said one more derivative, so like there's times where it says 2 more, then we would just done the step twice pretty much after that?
Yep, so then you do the second derivative. So you'd go
Gotcha.
derivative here, then you'd find the derivative of that derivative.
Okay.
Yep.
Okay. Makes sense.
All right. Any other questions on this one? All right, so let's do one more. And actually 2 more. Okay, so let's say, for example, find the 28th derivative of sine of x. Oh, I need that. At the point x equals pi.
0.
Yep, pretty much. Okay, so we know that if we're going to get 28, we have to divide 28 by 4. Okay, 4 goes into 28 7 times. 4 times 7 is 28, which is 0. Okay, so we know that our 28 is just going to equal 4 times 7 plus 0. So here, our remainder is equal to 0. Which means by the time we get done going through all the derivatives, by the time we end up to 28, we're right back at sine. So whenever your remainder is 0, your 28th derivative is equal, oh, forgot my sign. Sine of x is equal to sine of x. Okay. You don't have to worry about derivatives because there are no value of r to plug in. Okay, so now we just have to plug in our x equals pi. So when x equals pi, you get sine of pi, which is just 0. Okay, so that means our 28th derivative of sine of x at pi is 0. Which basically means you have a horizontal slope or horizontal tangent. Of sine of x at x equals pi is 0.
Can you just check sine of pi derivative?
Well, you could have, but you didn't really know where it would end up. So you don't know if you'd have a remainder of 1 derivative, 2 derivatives.
So we have
Like,
to,
yeah.
but even though we know like the multiples,
Oh yeah, even though you know
we
it.
have to write down that we.
If you just wrote in since,
Like if I on the test.
if you just wrote in 28 equals 4 times whatever or something like that, yeah, just something to show that, okay, you didn't just guess, you kind of knew where you were going with this one. If you just wrote that and then you went with that, I'd be just fine.
But if we just wrote 0.
All right, any other
0, we get
questions?
0.
You know what, I was about to say that. I was like, no, don't be a smart ass. Yep, I was about to say the same. Oh, I'm on tape.
Does it record audio?
Yep.
I didn't have one.
Hopefully I said it low enough, far enough away, where the microphone didn't pick it up.
That thing's pretty sharp. I watch one of the videos.
Oh, it is. All right. Any other questions on this one? All right. Okay, so let's do excuse me, one more. And I'll let you start on this one. What is the 43rd derivative of negative sine of x at the point x equals negative pi? Uh-oh. Yep, that would be
When you're doing the division by 4,
Mhm.
do you run it all the way out until you run out of decimals? Like, is it
Oh yeah, all you're looking for is your remainder.
just one number, or you want me to run it all the way out?
What do you mean run it all the way out? Let me see what
this
you're
one
saying.
is like. Is that what it comes out to?
Nope, all you needed was your remainder down there. Yep, you didn't need it.
So I only, okay.
Yep, you don't need it like
So
that
start
part.
with 7.
Yep, so as soon as you get your remainder and you can't bring
The
anything
first
else
one.
down, yep, you're
Okay.
you're all good. Keep good at changing. Actually, let me make a note to do that. All right, so for this one, first step is going to divide 43 by 4. 4 goes into 4 once, 4 and 4. Okay, 4 doesn't go into 3 at all, so we just put a 0 there. So that's our remainder. So we know our 43 is equal to 4 times 10 plus 3. Okay, so we know that our 40th derivative is going to equal sine. Okay, so,
Or it's gonna equal negative sign, actually, right?
nope, not for our 40th.
No, but
Oh,
the
yeah.
question's negative
But
sign
the
anyway.
question's negative.
Oh, negative sine. Well, negative 1 times sine, so,
Because it's gonna go back to.
yep, negative, well, it's still derivative, but it's negative 1 times derivative. So the same way we kind of brought the 4 down before, we just bring the negative 1 down with it. So even if you have, let me see, let's say the second derivative is negative sign, 4 more is still negative sign, and 4 more is negative sign, so it still has that 4 pattern. All right, so let's say the 40th, and we'll bring the negative out to the front, derivative of,
Why'd you go to the 40th derivative?
oh, just because of that.
Oh, okay.
Yep, so we know the 40th derivative is going to equal sine of x. So since our r is equal 3, r equals 3, so 3 more derivatives. Uh-oh. Okay, so the first derivative of sine is cosine.
We're doing the negative sign.
Oh no, the negative, I'll just leave that out front.
You can put it in later.
Yeah. Okay, so we have the derivative of cosine, which is your second derivative.
It's supposed to be negative cosine of x. Is that right?
Oh, yep, negative. Thank you. Sine of x is equal to, which is basically the derivative of cosine. So that's cosine is negative sine, so that ends up being sine of x. You have our third derivative. The x squared. Oh, should be third. Which is derivative of sine, which is again at cosine. Nope, we actually put our negative in there. Now, if we would have kept our negative out here, then that would have been positive. That would have been negative. Then that would have been
my question I
negative.
was going to ask is why didn't we use negative like we did in the very first higher order example? Like the second one, the second derivative would have been negative sine.
Yep, but normally what I do is I would keep whatever the coefficient is, I would keep it all the way to the end and then apply it. But since we put it in on the first one,
Okay, as long as it's
yeah,
in there.
yeah, I actually, if I went back to that, 'cause that's normally how I do it.
You need to put it over to the left side, right?
So negative 1, negative 1, negative 1. So here you have sine, derivative of sine is cosine, derivative of cosine is negative sine. And derivative of sine is cosine, so that would be negative cosine. Uh-oh. So that's why we have our negative 1 times negative cosine. Yep, would have given us cosine. That's what I did with my 4 before on the previous one. I just kept bringing the 4 down and down and down.
I
And
think
then,
pulling it out just makes it a little bit harder.
I know, but
You just-
I'm one of those, if I find something that works, I kind of stick with it.
Okay.
If I change up, I tend to confuse myself. So
Yeah, I see what you keep it as sine, that way you always stick with sine, so you remember only the sine pattern.
Exactly.
You don't have to worry about remembering the other pattern.
yep, exactly. So then I just bring it all the way to the end, then plug it in.
Yeah, I get it.
All right, so now, since we know that's the 43rd derivative, sine of x is actually our cosine of x. Now at x equals negative pi, our cosine